What happens when there are more than one gene from each parent that are inherited, and it's not just simple if I got one gene from one parent and one gene from another parent? For example, blood type has multiple alleles. There's the A blood type, there's the B blood type, and there's the AB blood type, and they are co-dominant, which means that if you have AB blood, you have both A antigens and B antigens on your red blood cells. Then they are co-dominant. If you don't have any antigens on your red blood cells, then you have type O blood, which is the recessive type. So homozygous dominant is the AB. Heterozygous would be either A or B blood type, and homozygous recessive would be type O blood. So what happens when you have two parents, one with a B blood type and one with an A blood type, and they happen to be heterozygous, which means that they are carrying a recessive O allele. So the female has immunoglobulin A, so A blood type is what she sees, and she's carrying a recessive O. The male is carrying the B blood type and has a recessive O. So each offspring that they have has a chance of having AB blood, B blood, A blood, or it can have O blood and be completely homozygous recessive, getting the recessive trait from both parents. So neither one of these parents may have known that they had a recessive O blood type until they have an offspring that has O blood type. Some genes are expressed with several traits, and we call those polygenic. So skin color and height are polygenic traits, but skin color can also be affected by how much sun exposure you have, and height can also be affected by the amount of nutrition that someone gets. So polygenic skin tones means that there are several genes that are going to be expressed in order to determine what base skin tone that you have. You can have something from very, very light, which is homozygous recessive for all, or you can have something that's very, very dark, and that's heterozygous dominant for all of the traits. Or you can have some variation in between. It depends on what the genes code for. There are pedigree charts that show family relationships and then phenotypes. So a blank one is normal, a colored in one is affected, and if it's half and half, it means that that individual is heterozygous and carrying whatever the trait is. So for an autosomal disorder, it means that you just have to have one dominant trait. So in this pedigree, the father is affected and is carrying at least one dominant trait, and they have 3 children that are also affected and 2 grandchildren. So it's autosomal, which means that it's on one of the autosomes within the cells, not the sex chromosomes, and it's dominant, which means that if they have it, they're going to get it, and they only need one copy. Autosomal recessive means that it is recessive and you only express it if you only have the recessive trait for the gene that's being expressed. So we have individuals who are carrying, which means that they have a dominant trait and they're carrying the recessive trait, which means that you won't see the effect of whatever they're carrying, but their offspring down the road will. So here, this couple here has 2 kids that are affected. These parents were both carrying the gene, and these 2 kids got 2 copies of that recessive trait. And this individual got it from his father, and this girl got it from her mother. In the form of the recessive trait is what they inherited, and they gave both copies to these two kids. If you have a disorder that is only on the X chromosome, then typically the female will be a carrier. They're usually not affected unless they get two copies of it. So here we have the mom's affected. Her daughter gets one copy of it, and she's a carrier. The son, however, only needed one copy in order to be affected. And this son gave that defective gene to his daughter, so they are carriers. This daughter gave the affected gene to her son, so they are affected. So if this was color blindness, this mom here is a carrier, and it's on the X chromosome, and so she gave the X to her daughter, and she gave this X to her son, so he was going to get it. He didn't have a choice because he only gets a Y from his mom, or his dad, sorry. And this dad, right here, because he has it, and he can only give that X to his daughters, they are going to be carriers, where they're going to get a normal X from their mom. So this daughter here got the X color blindness gene from her mother, and she's a carrier, but it's the only X she can give to her sons, and so they're going to be affected because they're only going to get a Y from their father.